The software-defined networking and OpenFlow webinar was made possible by the sponsorship of Big Switch Networks. Big Switch Networks are developing an SDN application for network virtualization, and you can get their open source SDN controller called Floodlight at the openflowhub.org. You can find Big Switch at bigswitch.com.
This webinar is just one of many vendor-independent data center and virtualization webinars available on IPSpace. To learn more about them, visit ipspace.net. And don't forget that you get immediate access to all of them with a yearly subscription.
Okay, as we get into the home slide, SDN for virtualization. So I read some bits and pieces about what SDN is. It's a provider and enabler for an integration of dynamic optical network services in cloud computing scenarios. Architecture and tools for composition of logical infrastructures that share the same physical substrate. And frankly, it's all consulto babble. Network virtualization is whatever you want to make it, right? Because virtualization is really a bunch of stuff. So VLANs are a virtualization technology, the very first. Networking had the first virtualization technology long before anybody else thought of it. MPLS is a virtualization technology, albeit it's been corrupted into a circuit technology using MPLS-TE and should be eradicated from the face of the planet, but maybe that's just a personal opinion. BGP, in relation to virtualization, is an MPLS technology. It's not a virtualization technology. Only challenges around this is, of course, that VLAN tags and MPLS tags are not inherently secure or even effectively separate traffic flows, even though we pretend that MPLS actually is. But whatever, your definition of virtual varies according to your mileage. So perhaps the biggest thing about OpenFlow is this ability to separate the flows and then to logically drive a tighter form of virtualization. OpenFlow has answers to most of the questions around virtualization, how to separate and how to handle. Okay. Things that we haven't answered are OpenFlow software-defined networking performance. So we've already talked about this in some of the questions in the break. We're very strongly in that, you can think there are applications of OF that you need constant updating of the OpenFlow fib. But this also means that the controller processing or algorithmic performance must be equally good, must be able to react to a given situation. This is a whole area which will shake out over time. I don't have answers, and I think we will see that progress. So don't ask, what happens if performance isn't good enough. The answer is that's a problem that your deployment would have to know, and that will take time to shake out. All right. A little bit more on the value of SDN is related to this process of today we have this sort of project which talks about planning, deploy, implement, operate, and optimized. And every project, those of us who work for large corporations or large service providers know that ITIL 3 thoroughly broke the IT model and structured it into some dumb model. It's like putting up a building, isn't it? Like you spend a whole bunch of money to put a building up and then you live in it until it falls down or is no longer viable for purpose. So each project deploys its own assets. We plan what's necessary, we deploy it, and then we keep adding more until the system is full. And it's very common in large corporate environments to no project when it's deployed never pays to recover unused assets. So how many servers and routers and switches are in your data center or in your networking environment are there because nobody ever paid to recover the dead assets? Because ITIL 3 says you only pay for what you need to add. It never pays to recover what is shut down and dead. So one of the value of software-defined network is it decouples, in my view, the planning and the deployment phase from the implement, operate, tear down phase. So today we want to strip away the ability to actually deploy physical resources into the system and optimize them as a physical thing. And we want to take the logical configuration and drop the implement services, operate services, and tear them down into a new environment. And this, of course, is very similar. Those of us who run VMware or KVM or Hyper-V will know that we can now instantiate a server. It's somewhere in the cluster over there. And when the servers no longer leave, we just turn it off. And it can stay on the storage array for a while. We need to be able to do the same thing for networking. And that is part of the value of what SDN can give us. The piece that's missing today that's also important is that while some of this is possible today, implement, operate, tear down with our current models, the part that's not missing is accounting, billing, recovery, and service termination. So this process of driving new software in the controller layer means that there is hope that we will eventually have lifecycle management of network implementation. So when we create a VLAN, how do we know that that VLAN is no longer needed? When a server is taken away from that IP address, how do we terminate that flow structure in the flow database? When that switch is no longer needed, how do we know that there's nothing on it anymore? Because there's no flows in it anymore. So to me, one of the greatest hopes of SDN is that we can now effectively count, bill, and go into service termination where we've never gone before because there's just not the right tools to see exactly what's happening inside of our network. Because if we go back those couple of slides, you can see the life cycle, you can see the stack, the software stack, the application stack, which will give us data about what's going on. So, as I said, today VMware Hyper-V have centralized management. So managing virtual hosts and their storage is actually relatively easy. Storage is centrally managed, VMware is centrally managed, but networking and security is a configuration disaster. The networking industry has been seriously abandoned of any intelligence for the last 10 years. We still twitch our fingers on the keyboard to configure switches and firewalls, and load balancer configurations are still NP hard. IDS configuration is such to the point that most people just don't bother. We have to come up with ways to address the configuration challenge, and I believe that early SDN wins will be in configuration management. It's an area that has the most pain, it's the easiest to sell, and it's the most likely to get the boss to shake some dollars out, right? If you go back to him and say, we need to do better management and operations and to, reduce the operational cost of the networks, that's where you're going to get the first wave of SDN. The second wave will be dynamic path networks, that is multipathing, campus multipath, or dynamic mobile applications in the campus. And the third wave will probably be virtual applications such as flow balance and firewall and security. Probably in the longer term, because it will take more to work out, is you'll see things in the carrier space where, as I said, there's literally hundreds of millions to be saved in a network by removing PEs from the network. So instead of programming the PE edge of your network using BGP, you'll program them using a net flow controller, which just says, here's the flow, here's the MPLS tag I want you to slag in. It punches it to the P and says, here's your MPLS tag for that. Away you go. And that's probably not as far away as you think. The carriers are really excited about this because it's the edge of the network that costs them all the money, and their edge is very, very large. So if you can reduce that down to a bunch of white box switches produced by a company in Taiwan using OpenFlow, they would save a lot of money. Okay, let's start to close it up. A little bit of a practical reality check. OpenFlow 1.2 was recently approved. Major vendors are participating in the OpenFlow standards at arm's length. OpenFlow is led by large companies such as Google, Yahoo, Verizon, but they lack focus on practical applications in the enterprise. So for normal people, my current concern is that OpenFlow is focusing on Google's problems and not my problems. I suspect that'll shake out over the time. Cisco, Juniper, Brocade, Ericsson, Nokia, all those companies are in OpenFlow either as a defensive play or actively. Juniper actively, Cisco more defensively. Draw your own conclusions as you will. OpenFlow Hub has several OpenFlow controllers to download. I put this here for completion. I'd just like to point out that NEC has programmable flow, which are commercial controllers and switches as a turnkey solution. And that's a real product you can buy today. They have reference customers that you can go and see, and they run entire data centers on OpenFlow SDN networking. A few more applications. FlowScale, which I'm particularly interested in. Big Switch, who also sponsored. They have their Floodlight controller, and soon, very soon, we will have a demo which you can see real stuff. This is a slide I took from Ericsson. I just wanted to put it in here to show you that this is really true. You can search it up, and it actually shows how Ericsson are building an OpenFlow MPLS aggregation point that interfaces towards the IP MPLS core and how they do the interoperability. This is a pilot for Ericsson, and they're singing about it because they see it as a major advantage for the future. So don't just think of OpenFlow as being an enterprise data center, cloud scale, hyperscale application. There are other things as well. So OpenFlow will be soon. I think that there are many startups in the space. You'll see a lot more to come. I have every reason to believe that the technology is sound. I specifically left out the slides here, but the pedigree of the people who initiated the OpenFlow standard make me believe that there are strong opportunities for it to be successful, and there certainly seems to be a lot of coherence around the technical challenges. The big vendors don't seem to be much interested. You could interpret that as busy defending their turf, but that might be unkind. I think the big vendors have seen standards come and go over the years, and they're just bitter. And a few years ago it was NetConf and Yang, and that went nowhere. Before that it was SNMP, and before that it was, there's been dozens of good ideas that are founded on the brutal reality of the future. That said, my gut feel is that OF/SDN is a technology that's now calm. The barriers to adoption, such as poor code or poor development practices, are probably past.
To get more information about IPSpace webinars, please visit ipspace.net.